My name is Wentao Zhang. I'm the product manager for Interoperability solution that involves structural Synchronizer, ISM Link, and both of which will be discussed today. The topic of today is interoperability between Revit and RAM via ISM, and is aimed at existing users of ISM Link with RAM. All right, let's get started. So the agenda for today. Firstly, I'll be covering ISM refresher. So that is just to ensure that all of us are on the same page and understand where ISM and structural synchronizer fit in the process. Next, we're going to cover how each respective application, that is your Revit, ISM, and RAM, how they see structural data, because each of them have its own modeling constraints and its way of representing structural data. So understanding how each of them represents this goes a long way into making interop smooth. Then we'll cover some common issues that we see when we're dealing with service requests. And we will also go over strategies for better interop for mapping, modeling, and update. So what is ISM, or Integrated Structural Modeling? ISM is Bentley's standard for structural interoperability. Simply, you can think of it as a file format for import-export with a .ism.dgn file extension that enables you to do multi-product workflow as you see on the screen here. Notice the arrows are bi-directional as well. But more than just a file format, it can also track changes. So each time you push and pull from your repository, your source of truth, you're given a chance to comment on this. And as your project progresses, you can always look back at what you've done between revisions. You can merge revisions, you can undo revisions as you see fit. To those of you that are program inclined or VBA inclined, the ISM also have an SDK and API expose, which allows you to do custom links and custom application. But I'm sure a lot of us will be using Structural Synchronizer and ISM as a user. Okay, so to create and update models, I have two screenshots here. The top is in RAM Structural System. When Structural Synchronizer is installed, the file ISM menu is enabled, it's not grayed out. And likewise, if you have the ISM Revit plugin installed for Revit, under the Bentley tab, you get to see similar 4 icons here, the 4 workflows that's allowed for you. Just to cover these briefly, from your application data, so let's say I have a RAM model, when I create an ISM repository, I'm pushing my application data into this source of truth, into ISM repository. When I do a new from ISM repository, I start off with a blank file, blank application data, and want to pull information in. So that's called new from ISM repository. And when I do incremental changes, that is update ISM repository. Okay. And the converse of that is I want to do an update from ISM repository if my ISM repository have additional data that my application do not have. So that's update from. And the idea is you can repeat this as often as you like. Both RAM, ISM, and Revit, both of them can progress in parallel. It doesn't have to arrive at a certain point before you push data back and forth. Next, let's look at some key ISM concepts, and there's 4 here that's quite important. So each ISM object, not just physical objects, not just your beam, column, brace, walls, and slabs. Each object, for example, a column having associated section and associated material, they themselves are objects. So each of them have a unique internal identifier, so a unique ID, and they are presented as just 6 digits. Okay, and that is how ISM tracks addition, deletion, and modification of objects. Let me quickly jump to the next slide just to show what this is. So each time I do a ISM operation, the ISM ID is stored simultaneously in RAM Structural System in ISM repository, as you see there in the bottom screenshot of the same short ID. And likewise, if I pull that in, it will go into this column there on the top right, which is a Revit column. Okay. So understanding this is important because let's say, for example, in RAM structure system, you delete an existing column and you add in a new column that's physically identical. But because of the fact that it doesn't have the internally stored ID, when you're trying to do an update ISM operation, we end up seeing an addition of a new column and a deletion of an existing column when you were expecting no changes or perhaps modification. And if, let's say, you didn't delete this column in the first place and you just move the object because internally it has the ISM ID, when you do an ISM update operation, it knows to modify the location properly, so appear correctly as modified, and in blue in structural synchronizer. Another reason why the ISM ID is important is sometimes when you see error messages or warnings during your ISM import-export, they sometimes refer to the ISM ID of the object. And knowing that, you can find the particular object in structural synchronizer. Okay, then, so for nodes, next we have nodes. So nodes are slightly different to what we're accustomed to when we're dealing with finite element analysis programs. So it's not finite element analysis nodes. In ISM, nodes are objects that tie together connected structural objects. So that's your beam column, column slab, brace column, etc. And then they're added and removed by analysis applications as they see fit. Each analysis application usually have a add node or remove node tolerance setting as well. Okay. Next in ISM we have stories. So this is pretty self-explanatory. It is equivalent to levels in Revit and layouts of stories in RAM structure system. And it's a group of structural members belonging to a story, belonging to a certain elevation. When it comes to sections in ISM and Revit and RAM, there's really just two types, which are ISM table section and ISM parametric section. Okay. So ISM table section is commonly for your for steel, so they pull from a standard section catalog, and for parametric section is a parameter shape. So for example, solid rectangle or circular, if you will, and they're usually for your concrete columns and beams. Okay, let me jump on over to structural synchronizer. So over here I have a Revit model, a very simple Revit model. From this Revit model under Bentley create repository, a ISM repository is produced in here like so. So from here I'm going to illustrate those 4 ISM key concepts. Okay. So this is structural synchronizer. Firstly, I talked about ISM ID or short ID. As you see here, all the elements within structural synchronizer have a short ID. So anytime you search for, let's say, the error warning message that's presented, and you just search for a particular ID, you can just type in here. Okay. For example, let's say the error warning pertains to member 374590. And then you can see on screen is this particular column. So what is it about this column that it did or did not work during import? And you can interrogate from here. So that's ISM ID. Now for nodes, nodes connect elements together. So on screen, if we click a node, one node on here, for example, this node, okay, it's a point in space, right? And it's got associated members. So down here, when I click members, double click members, the associated members are highlighted. So what this is saying is all these members are associated to this node. Okay, so it's structurally connected somehow via this node. It's not limited to just linear members. Okay, so your wall, column, beam, slabs, all connected via that node. So nodes are important as well. Next we have stories, ISM stories. So here, in Structural Synchronizer, you can always group items by their column header. So if I want to view them by their type, I can always group by type. And under here, it's all the curve members listed. Stories, still. We can also group members via story. So this is showing all the members belonging to this one story. Okay. Now we want to look at the two different types of ISM section. So here you have a table section. So when a member is selected, you can always come down here, go to double click the section, and we see it belongs to Standards Organization BSI and has this section name. Okay. And from here you can also see all the members that are assigned to this section. Double clicking this, it highlights it on screen for us. Now for parametric section, there are your rectangular your rectangular shapes here for your concrete beams. 300 by 600 mil. Parametric shape, solid rectangle. Okay, with these dimensions. Also within Structural Synchronizer, I mentioned before, it's more than a import-export. It tracks entire record of design history. So when I previously created this, I had an opportunity to comment on this revision, right? So Revit sample, simple model created for demonstration of ISM key concepts. And then for any model within Structural Synchronizer, you can always publish the IFC and also push the iModel, which is Bentley's Bentley's format for sharing data. Okay, so with that, let me get back to the presentation. So previously we covered how ISM sees data. Now the other players that's involved, RAM and Revit. Let's see how RAM sees structural data. Okay, so right off the bat, it's floor-based modeling. That means your beams, columns, decks, and walls, they all have to belong to a floor. And the way it's modeled, it's always in plan, with the exception for walls and wall openings. You're given an opportunity to model them in elevation. But largely, items need to belong to a story. Okay, and floor slopes are determined by supporting columns and wall elevation. In majority of cases, is leveled. There's also a difference between gravity and lateral members for whether you're analyzing them in concrete or RAM frame. And also, we can't just bring members in and just be satisfied with that. It's at the end of the day, it's an analysis program, so it must be framed to run. So your RAM modeler integrity data check must pass. Okay, so that adds an extra layer of complexity. When it comes to beams for supports, you can have simple beam between two supports. You can have cantilever backspan with an extension. You can have stub cantilever. Every beam must have exactly two supports, never one or three. And those supports must be on the same level type, so you can't directly model a bent beam forming a gable unless there's a support at the peak. What's important as well is you must be able to model the structure as a flat wedding cake type structure first, and then you create the slopes by changing columns and wall elevations. And anytime you have a step, that's two beams framing into the same support at different elevation, two level types and two stories are required, and the higher beam must be on the higher story. So you see there's many, because of the fact that it's floor-based modeling and many of these other limitations, you compare this to Revit. It's freeform modeler, right? So how does Revit see structural data? It's freeform modeling. Anything goes. On top of that, there's no structural checks. Okay, it doesn't care if there's a proper low path going all the way down. And oftentimes, for support requests, we see Revit models that quote, quote, looks right, but its associations of elements to stories are not correct. Okay? And so Revit do have levels or references, but that's optional when it comes to the user setting them. It doesn't enforce or doesn't force the user to set them correctly. Another thing as well, the ISM repository produced from Revit will always visually appear the same as in Revit. So user gets the impression that the modeling was correct because it looks correct. But there are many settings they need to be mindful of if you're modeling with the intent of analyzing in RAM. Okay. So when it comes to levels, this is pretty much a one-to-one relationship. So on the top here, you see Revit levels. So there's a name and an elevation. Likewise, an ISM that's called stories. And in RAM structural system, that's either called layout or story data. Okay. The way RAM structural system produces story is completely based on the levels you set in Revit. And it's important to be mindful of that and set that correctly up front. So in ISM, beams and slabs are associated to a story. So this association is created by Revit's reference level. So in yellow there for beams and your slab, you got your reference level and your level constraint. Make sure these are set correctly. And then since RAM structural system will base story creation off of what's in Revit, your beams and slabs should physically sit on the same reference story. This is really important. You want to make sure your Revit beams don't just physically look correct. For example, if you have a reference level all the way to the basement, but your beams is actually physically on the 4th or 5th floor with a huge level offset, that's not the right way to model. The right way to model is to set the beam to that 4th or 5th floor. And if there isn't a floor, you need to create a floor, because whatever story or floor data you have in Revit comes into RAM structural system as is. In ISM, columns and walls are not associated with story, but the story it belongs to is worked out from its elevation. If you want your floor to come in level in RAM structural system, you want to avoid offsets to column and walls at the top, particularly where slabs frame into it. Okay, so in here you want to set your base level and your top level for your structural columns, likewise for your walls. Okay. So here I'm illustrating some invalid or error arrangements, and to highlight what's going on. Okay, so on the left is a screenshot of what it looks like in ISM. In the middle is what it looks like in Revit, and on the right, what it looks like once we brought it into RAM structural system. It came in okay, but when we run integrity data check, we get this error here: beam number 2 not supported on left end on layout type level 2. Either delete beam or put in support. So it turns out what happened is when the user modeled the beam connecting to the supporting beam, because it's a freeform modeler, it didn't properly snap. Okay, so turning on snap is very important in Revit to make sure it's properly supported. So the way to fix it, of course, is trying to model it correctly up front. and that should always be the first approach. But there's also a workaround RAM structural system to deal with situations like that. Okay, so during ISM update or ISM operation, under operation settings, under node generation, a lot of users tend to accept the default, and that's correct. But for this particular case, we can adjust the default slightly to make this import work. So we can adjust the connection proximity and the node merging tolerance, change them from a default 1 inch to a 6-inch sphere. What that means is for members where beam ends and nodes situate within a 6-inch sphere, connect them and collapse all of these into one node. That's what it means. So that allows the structure to come in and pass integrity data check. Next, we have this example here. It comes in RAM structural systems okay, but cannot analyze. We get this warning. Of course, and the warning is pretty self-explanatory. So in RAM structural system, it matters a lot whether your members are gravity or lateral. So you want to set this correctly up front. So in this case here, we have lateral members on top of gravity, which will not do. So in Revit, under your Analyze As for the dropdown, you want to set that correctly up front. Again, another instance where Revit being a freeform modeler, so you have two physical beams, right, crossing each other. And in RAM structure system, that doesn't work, and it's telling you to fix these beams. So you want to correct these upfront in Revit by splitting that beam into two. Okay, so for this example, it comes into RAM structural system okay, but again we get integrity data check error. We have two cantilever, it's free and it's connected, but it's statically indeterminate. This is not allowed in RAM structural system. So the way to fix that is to change one of the beam ends into a stub cantilever or have them disconnected up front in RAM structural system. You see what it looks like when it's imported into RAM structural system. From here, we understand the intent by the user. They want to create a cantilever. But unfortunately, if the connection assignment is not set properly, RAM structural system wouldn't know to create that as a cantilever. Okay, so when we do integrity data check, it's complaining that beam number 1 not supported on right and on layout type level 2. And the way to fix that is highlighted in yellow there is to make sure the start connection set to moment frame in Revit up front. And if that is set, then that comes in as a stub cantilever in RAM structural system correctly. Here's a case that is handled correctly quite well. So we have one physical member with 2 column supports, and it comes into RAM structural system quite well. You see there, it has a span, it has a cantilever. Now, what if the user have 2 physical member with 2 column support and cantilever moment connection tag on connected ends, but analytically, they want it to be treated as the same as what you saw in the previous slide. So RAM structural system does deal with this case. It recognizes that if at adjacent points with connection tags of cantilever moment, it knows that when to bring it in as a cantilever, as you see here. But being mindful that because in the ISM repository that's produced, the main span and the extension was actually split into 2, right? So that means when you go out in your ISM update operation to get it to operate smoothly, you want to ensure you check split cantilever extension, and they will recognize the internal ISM ID and update properly. Next, we have a case where if you were to model this in RAM structural system standalone, it wouldn't allow you, but because it's such a common arrangement that we see in Revit that we've dealt with it automatically. So here we have one physical member with multiple spans. Okay, so that's automatically split on import, and internally it tracks the ISM ID for update in RAM structure system. What that means is for update operation, RAM structure system sees that these split up beams have the same ID, reconstitutes them as one physical beam, and compares with the ISM repository, and it will show up as no changes. For walls, there's really only 3 points to really get across. You want to avoid openings across story boundaries, even though the link does handle that for you. If it's within your control, it's best to split up openings if you have them crossing story boundaries. And curved walls is not supported because that type of structural entity just does not exist in RAM structure system. And as mentioned before, you want your walls, base, and top reference story set, and you want to avoid offsets. So common issues we see, some of the examples I've already covered, framing issue. So they really have to do with the way the Revit model is snapped. They might look correct, but actually they're not connected. And for cantilevers, you want to set the start and end connection tag. And just really be mindful of the fact it is a floor-based model in RAM structural system. So when you're modeling in Revit, just be mindful of that. Sometimes we get support requests relating to the ISM import went okay, but when they see the model RAM structural system, it looks like the floor was protruding all over the place. Okay, so what's happening here is the way RAM structural system deals with floors. The floors themselves don't have a slope property, if you will, like you do in Revit. The floors are sloped completely as a function of its supporting column and wall elevations. Okay, so that's why it's very important for your column and wall offsets in Revit to set them as 0 and just set them to have top level constraint to a floor. And then once you do that, it will come in the RAM structure system nicely. Sometimes we get stories missing, errors. So if your ISM repository is completely devoid of stories, RAM will try to create stories for you on your behalf. It scans the model, looks for unique elevation in the elevation value in the Z axis, and attempts to create these stories for you. But because creating levels in Revit is so trivial, and it's such an important step in this overall interop, it is always recommended to create these correctly upfront. Remember, as a one-to-one relationship, Revit stories to RAM structural system stories. Okay, it's very important to set these correctly. Okay, let's quickly jump to mapping best practice. So you want to set up your Revit mappings database file. You have a couple of paradigms you can choose from. You can be project specific or office specific. You set this up once, distribute it amongst your project team or your office. And you don't need to start from scratch. You can copy existing database file, and that is literally copying the .db file in Windows Explorer, copying it, pasting in the same folder, rename it, and make the necessary changes. External family catalog is when during mapping you want your Revit families, whether they are the standard families or custom families, if you want them to be considered for mapping, they must be added in the external family catalog. And table sections are handled automatically in ISM, is looked up against a sections catalog, database. For parametric sections, I'll cover these shortly. It's handled to and from ISM via mapping dialog settings. So for table sections, right, we see here on the right the type of standard sections that are in the catalog. You can select the table section standard relevant to you, or you can just do a select all. It will eventually find your section, but it might just take longer. Okay, and notice in there you have steel joist standard as well, SJI and SJIM. Now, how about parametric sections? So to translate this in layman's term, what it says right there, ISM section creation template. What does that mean exactly? So it reads like this. When encountering the following Revit family, create the following ISM parametric section. So as it's pushing the Revit family, the Revit project into ISM when it's looking for a Revit family, and it encounters, what does it say right there? Concrete rectangular column. Create a solid rectangle ISM parametric section with the following parameters mapped: h to height, b to width. Okay, so that's how that reads, going in one direction from Revit to ISM. What about the other way around, coming back? So coming back is where it's one selection below that. It's family type creation template, and that reads, when encountering the following ISM parametric section mapped to the following Revit family type. So when coming back, when encountering a solid rectangle, map that to the previous Revit family, which was concrete rectangular column, and map them to b to width and h to height. Okay, so these, you set this up once and you save this, and or remember this for subsequent ISM operations. Just to summarize again really quickly for modeling best practice, it is always easy to model correctly upfront in Revit and be mindful of export to RAM structural system. You want to make sure your levels in Revit reflect those in the structural model. And then your Revit columns and walls should start from one level and on another. Avoid offsets. And it's very important to use the correct member type as well. It doesn't just have to look correct. Internally, it has to be correct as well. So for example, don't use the beam element as a vertical brace. That would not work. You can also selectively create ISM repository by selecting elements on screen in Revit. What I mean by that is you can have a subset of your model in Revit push to an ISM repository. You don't have to push the entirety of your model into ISM. Finally, when it comes to update best practice, what we recommend is to incrementally commit changes to ISM and can be mindful selective. So when you do an ISM update operation, by default, it shows a lot of objects either added, modified, or deleted. A lot of users just do a select all and accept, but you as the engineer have ultimate control over this. So you can select objects to accept, or even select properties within objects to accept, for example. Okay, so and it's also quite common to commit when the structural framing is modeled. For example, in Revit, when you have the skeleton or the bones of your structure in there, feel free to create an ISM repository from that, and then from there, create a RAM structural systems file and see if it passes integrity data check. And then in parallel, the two can work together as you add more structural detail, more structural information in Revit, push that to ISM and try to pull that into RAM structural system. Okay, there's nothing stopping you doing this push and pull between these three domains. And in our latest version of Structural Synchronizer, we have this tool called Properties Comparisons Settings. Okay, and what that deals with is a question from the user where everything is blue on update or everything is modified on update. And why that is no matter how inconsequential the property modifier is for an object, it will always appear as blue if it's modified. So if you only care about certain properties to compare, you have the power to control this. So property comparison settings. Okay. So in here you can enable or disable these or modify the tolerances. So if it exceeds a certain tolerance, then you deem it to be worthy to show up as modified. Okay. So with that, thank you for attending. So in closing, I just want to draw your attention to the great resources we have here. We have Bentley Communities, which is our online community, forum, wiki, blog entry, tech notes, what have you. If you've got questions, you can always post there. One of our technical staff monitors this blog, and we have users that are also quite active on there as well. So you may find that your question has already been asked and answered before, or they may answer for you. And also our YouTube channel. Okay, we've got a lot of great content there on YouTube. Just search for Bentley Structural, one word. You'll find lots of great video series on there as well. And of course, feel free to email me. My email there, wentao.zhang@bentley.com. Feel free to email me any questions and comments. Yeah, so with that, why don't we open? Okay, thanks. Lots of great questions. Feel free to type them into the Q&A box. All right, we got a question here regarding STAD. Okay, so can you do the same thing with STAD? Okay, yes, certainly. So this particular talk concerned only two of the interoperability pairs. If you remember, we in one of the first screenshots, there was a graphic showing the many ISM-enabled application. So all of them can participate in this workflow, so to speak, and STAD is one of them. So in STAD, as you know, it's a general purpose finite element analysis program. It is less constricted than RAM when it comes to just modeling as you see fit. It's not floor-based modeling. So pretty much whatever you have in Revit, you can bring that in with quite high fidelity into STAD Pro. With STAD Pro Connect Edition, we have two workflows. So they're the analytical workflow and the physical modeler workflow. Both of them have their own ISM implementation. So with the analytical modeling workflow, it's what you're accustomed to. So that's where the user have to add beams, add structural beams and nodes themselves and connect the structure themselves. Whereas for the physical modeler workflow, modeling is abstracted away. So you're actually modeling physical objects. So you can have a interior beam connecting to a longer physical beam, and you don't have to manage that or split that up. So yes, if using the STAD Pro physical modeler, it will be closely aligned to the type of model you get in ISM and also in Revit. Can we do IFC? Yes, certainly. So the question is, can we do IFC export and import for any ISM repository? Once you open the Structural Synchronizer under File, IFC, there's opportunity to import and export to IFC format. How about other file formats? Okay, yes. So I touched on this briefly when I showed Structural Synchronizer. So the question is, how about other file formats other than IFC? So once you have the ISM repository, you can publish an iModel. So in Bentley, we have this quote, we see iModel as a currency for information exchange. So what that means is you can view, interrogate, and review your iModels with Bentley Navigator and Bentley Structural Navigator. So you're not constrained in your office either, because we have that available for desktop, iOS, and Android devices. All right, we got a question here regarding what can you edit in ISM repository? Okay, so the question is, what can you edit in ISM repository and Structural Synchronizer? Can I directly change or modify objects? Okay, right, so Structural Synchronizer is really a tool to help you synchronize objects, if you will, between different applications. And allows you to view the state of your ISM repository at any point in time or any point of the revision. So for the time being, we don't really allow directly editing of objects in structural synchronizer for an ISM repository. As a workaround, I mentioned before where the Step Pro physical modeler is a high fidelity import-export to ISM. So as a workaround, what you can do is you can pull in a ISM repository into Step Pro Connect Edition via the physical modeler, do changes from there, and then do an update ISM operation. And that should achieve what you're after. All right, is transfer of loads possible? Yes. So ISM repository produced from RAM do have loads, and they come across the Revit. In the ISM Revit link, there's load mappings as well, so you can map to load cost, etc. All those Revit specific properties for loads. Joists in Revit, how are they treated? That's the question, I believe. So I touched on this briefly when I showed a screenshot of the table section in Revit. So joists are exported to ISM and it's consumed by RAM structural system. And that's fine. All the standards ones come through, no problem. If you want to add RAM special joists and girders to Revit joist families for those instances, we've actually written up a great article on how to do that specifically. So on Bentley communities, I believe if you just type in the search bar ISM Revit plugins support, there are a lot of articles on that page. One of the first article, it's add RAM special joists and girders to Revit joist family. And then there details a small text file that you can modify in the Revit family libraries to get that to align with your RAM special joists. And this includes SP, CS, and joist girders. Transfer of rebars. Okay, great question. Okay, so we've added the ability, so this is near the end of last year, we've added the ability to transfer rebars in Revit, ISM Revit link. So as we know, like RAM concrete column concrete beam can design individual bars. So that gets transferred into ISM repository, okay, as individual 3D bars. And we have the ability to bring that in to Revit as individual 3D bar objects. And in fact, we did a talk on this previously. If we go to our YouTube channel under Bentley Structural, there's a previous webinar done by Josh, Advancement in Structural Engineering and BIM Collaboration, and there it showed RAM, Step Pro connection, ISM, and even an example of a complete round trip between Revit, RAM concept, and back, showing the transfer of rebars and finally producing drawings in Revit.